Okay, so for this one, someone asked to do, and then so we're in 1.5. We're gonna do 6, 8, and 9. Okay, so 6, 8, and 9. Here it is. Sorry, I'm just finding it on my iPad. Okay, so number 6 says, so Claire had $300 in an account, and she decides that she's going to take out half of what is left there at the end of each month. And then so up here, if you notice, they wanted you to write the recursive and explicit for the geometric. Oh, it's geometric? They just told me. I don't even have to like think about whether it is or not. And then it says, finally graph the sequence, making sure that you clearly label the axes. Okay, so so again, I want to use a table. So I'm going to copy this table because I want to use it over here. So it says, so Claire has $300 in account. So in the very beginning, she has $300. And then she's going to take out half of what is left there at the end of each month. So so she's taking half every single time, right? So let's erase that. So if she takes out half, it means she's left with 150. Okay. If she takes half again, then she's left with 75. If she takes half again, what is that? 37.50. Yeah, $37.50. And then so on and so forth. So the expression that I got for 150 is the 300 times 0.5. And then I did it again. So that's 300 times 0.5 times 0.5. And then if I do it again, that's the 300 times 0.5 times 0.5 times 0.5, right? And so now you can kind of see the exponent thing happening there, right? Right, you see that exponent. So here, this is going to still have that 300. And then I'm going to have these 0.5s to the, and the big question here is what is going to be my exponent? So in this case here, 4 had 3, right? Had 3 of them, 3 factors, 3 had 2 of them. And so now you're used to seeing as, oh, Ms. Johnson, it's just going to be to the n-1. And you're right, right? So if you're ever like, I don't know what exponent to use, look at this number versus how many you have, okay? So there goes my explicit rule right there. It's, let's see, I'll use f of n. So f of n is equal to 300 times 0.5 to the n-1. And Ms. Johnson, how come you put the 0.5? Why'd you put the n-1 in parentheses here, but you didn't over here? And the reason why I didn't was because it's clear to me who the exponent is here. Like, see, it's up here. Here, it's not clear who the exponent is. So that's why I included it there. Okay. The other thing is, Ms. Johnson, why did you put a 0.5 in parentheses here, but you didn't do it here? That's just preference. I just wanted to make it clear that it was a 0.5 and it's not just a little fleck of dust. I don't know, something like that. Okay, so your recursive function is going to look pretty similar. It's going to go f of n is equal to f of n-1 times 0.5, where f of 1 was our $300. Okay, so for those of you who are like, Ms. Johnson, my gosh, is this like, how do I know what to do? Well, here, when it said half here, that showed up here, which showed up right here and right here, right? That 300, you can almost think of it as like the starting point, right? It's its initial value here. It shows up here, all here, and here, and here, right? So just get used to knowing where people go and where people sit, okay? So that's number 6. Number 8 says, use the middle column in each of the given tables to write the process of number patterns that relate to your input and output. Then create a recursive and explicit rule for each one. So here, if you notice, so pretend that I can't see this, right? So here I just see this 3, 6, 12. And remember, I really like tables. And so whenever you give me a table, I'm going to be able to figure out a lot of information. So here I'm going to say, hey, I'm just going to pretend I don't know this is geometric, right? I'd first subtract and say, oh, 6 minus 3 is 3, but 12 minus 6 is not 3. So it's not arithmetic, right? So then I'm like, oh, it must be a geometric because look, I can go 3 times 2 is 6 times 2 is 12. Okay, so we're really good here. So this is times 2. And if you remember where this times 2 goes in my function, you'll see it over and over and over again, right? So so that's number 1. Okay, so then it says write your recursive and explicit rule. So some of you already know that that 2 is going to show up over and over again, right? So I want to make sure we understand how do we get from here to here. And so again, I'm actually going to go out of order and I'm going to do the recursive and explicit rule first, right? Okay, so for here, what I do is I would take this 2 and you know where it goes in my explicit form. It's going to be 2 to the like some like exponent up there. So here I'm going to get this guy by multiplying 3 times 2, which would give me my 6. Right? And here, this is going to be 3 times 2 times 2. And this is going to be 3 times 2 times 2 times 2. Okay. And so there you see all your exponents. Here I need 3 of them, but you want to give me 4. So notice here I'm going to go with -1 as my exponent. And then you'll notice that this base right here is the 2. And this 3 stays the same. So he's just going to stick out in the very front. Okay. And you should remember from the law of, not the law, the PEMDAS rules, right? We don't multiply these two before we take care of this exponent. So that's why we get the accurate numbers there, right? So here's my function. So I'll write this as f of n. And then for explicit, it's going to be the same. It's going to be f of n equals to f of n minus 1. And what am I doing every single time here? What am I doing every single time? Well, I'm multiplying by 2. So I'm going to multiply this guy by 2. And I'm going to say, hey, by the way, you're going to start at 3. I need you to start f of 1 equals to 3. Okay. Last but not least, and problem number 9, very similar to the previous problem. I'm going to figure out my multiplier here, which some of you already know what my multiplier is. It's times by 3. Okay, and now you can kind of see, okay, where does that 3 show up in my recursive? Where does it show up in my table, right? Okay, so here I'm going to write this one down as 9 times 3. And I'm going to write this one as 9 times 3 times 3. And then again, 9 times 3 times 3 times 3, right? Here. So then you can kind of see my explicit formula already forming. So it's 9 times 3 to the n minus 2. Now, this isn't the only rule, right? This isn't the only rule. This is the rule that I see based on what I wrote here. Now, some of you are thinking, but Ms. Shelton, you can rewrite 9 as a base of 3 too. Yes, I can. But based on how we've been seeing them, I'm going to leave it like this, right? So here's my f of n. And then for my recursive rule, it's going to be f of n is equal to the previous guy, f of n minus 1 times by 3. By the way, f of 1 is 9. Okay, so one of the things that I would really like you guys to get better at is this. Where does this 3 show up in my rules, right? Where does that 3 show up in my rules, right? And for some reason, it is not syncing. There it goes. So where does this 3 show up? And so hopefully you guys are seeing like, man, Miss Johnson, I see that 3 everywhere. And I'm like, okay, well, where? I see it as the multiplier off to the right of the table. I see it inside the table as your many, many factors of 3. Exactly. I see it as my base in my rule. And I see it as the multiplier in my recursive. Exactly. You should also see this 9. Oops, that was supposed to be a different color. You should also see this 9 everywhere, right? Because, you know, he also shows up in different places. All right, hope that made sense. Bye.